Electricity plays very important role in our day-to-day life. Life without electricity is very difficult. The electricity in a life of a human being made the life of humans very comfortable. You can't imagine your life without fan, without the tube lights, without the refrigerators, without the micro ovens, even the mobile on which you are seeing my video lecture or the laptop on which you are seeing my video lecture also runs on the electricity. Therefore, electricity is everywhere, it is needed everywhere, and it is supposed to be the country which used to use more amount of electricity per capita per person is supposed to be the rich country. आपल्याला माहिती आहे की आपण इलेक्ट्रिसिटी शिवाय जगू शकत नाही. प्रत्येक गोष्टीमध्ये इलेक्ट्रिसिटी आपलं आयुष्य आपल्याला कम्फर्टेबल करत असतं. ज्या देशांमध्ये प्रत्येक व्यक्तीच्या मागे वापरली जाणारी वीज जास्त आहे ते देश समृद्ध समजले जातात. Now, in this video lecture, we are talking about the current electricity, in which we must know what do we mean by the electric current. To start with electric current, one should know there are two types of charges, the positive charges and negative charges. Negative charge is an electron. Electron is a negative charge. Quantization of charge is that the charge Q is nothing but the n number of electrons having a charge E. Unit of charge is coulomb. Now, atom is supposed to be consist of centrally situated nucleus which is positively charged and electrons revolving around the nucleus. In the first orbit there are 2 electrons, in the second orbit there are 8 electrons, like that. Electrons in the outermost orbit are supposed to be the valence electrons. In conductors, electrons in the outermost orbit are loosely bounded. The attraction between the positively charged nucleus and negatively charged electron is comparatively weak. At the same time, electron in the outermost orbit of the atom is attracted by the nucleus of another atom, neighboring atom, and because of that, with a little force acting on it, with a little external force applied on it, the electron dislodges from the atom. Electron dislocated from the atom, and when this electron is made free from the atom, it is supposed to be the free electron. This free electron is a negative charge, and absence of electron in the atom is nothing but a positive charge, because initially the electrons and the nucleus together atom is supposed to be neutral in charge. When the electron is separated from the atom, the electron is a negative charge, and what the remaining is a positive charge. Like that, we can say the positive charges and the negative charges. The proton is positively charged, it is inside the nucleus. Therefore, nucleus is positively charged, it consists of proton and neutrons. And the positive charge on the nucleus and negative charge on the electron together make atom neutral. But when electron is dislocated, the electron itself is a negative charge and the rest of the atom is a positive charge. Otherwise, we will say that the absence of electron is nothing but a positive charge. This is about the charge. Now, thereafter, the charges are of two types. One is positive charge and other is negative charge. And when we are thinking of the study of charges at rest, when I am saying that when the charges are at rest, then we used to say that we are studying electrostatics. Static means rest. Electrostatics deals with study of charges at rest. In electrostatic, which is another chapter in which we have to study the charge quantization, then the like charges attract each other, unlike charges attract each other, unlike charges attract each other, like charges repel each other. The force of attraction or repulsion is given by Coulomb's law. From that there is electric field intensity, electric potential, potential difference, the electric lines of forces, so on and so forth. This is all we are thinking of about the charges which are at rest. That comes under the electrostatics. Then the study of charges in motion is called as the current electricity. The current electricity deals with study of charges at rest. In this chapter, we are thinking more and more about the study of charges at rest. It means that we are thinking of the motion of charges. Now, what current is? Current is nothing but it is the rate of flow of charge. The current is rate of flow of charge. The current is rate of flow of charge. Therefore, I will write I is equal to Q by T. The average current passing through a conductor, I average, is equal to, it is delta Q divided by delta T. That is the total number of charges crossing per unit time through a particular cross section of the conductor is the average current. And the instantaneous current at a given instant of time is given by dq by dt, means for a short interval of time what's the current flowing through it is dq by dt. Now, the unit of current, obviously what we expect is that the current unit of charge is coulomb and unit of time is second. Therefore, unit of current is coulomb per second. But coulomb per second is equal to ampere, and the ampere is supposed to be the base unit which is taken as a SI system, base unit in SI system of unit as a unit of current. And 1 ampere is equal to 1 coulomb per second. How it comes, that we will see earlier. Now we will see next to this one. This is all about what is current. Now just we see what do you mean by the charge, what are the types of charges, and what is current and unit of current. Hereafter we will see how is the current through a conductor. Substances which are able to conduct electricity are called as the good conductors of electricity, and substances which are not able to conduct electricity are called as the bad conductor of electricity or the insulators. Semiconductors are the substances which are able to conduct electricity under certain conditions. All the metals are very good conductor of electricity because all the metal consists of large number of free electron. Let us consider, I am drawing here a conductor. This is a conductor of length L. It has large number of electrons. It means that the electrons in this conductor are free electrons. They are able to move in a given direction, in any direction. But a conductor which is not connected to any source of energy doesn't conduct any electricity. एक कंडक्टर आहे, तो टेबलवर ठेवला आणि त्याला हात लावला आणि शॉक लागला असं होत नाही. In a conductor there are large number of free electrons and the free electrons are moving in any direction, in any random direction. Therefore, the electrons moving in one direction is equal to electrons moving in another direction, so that the net flow of electron is equal to 0. The net flow of electrons in a conductor is equal to 0 when it is not connected to any external source of electricity. This conductor contains large number of free electrons. It means that the electrons in this conductor are free to move. At the same time, it has positive charges. At the same time, it has positive charges, but electrons in this conductor are able to move. Therefore, these are said to be the free electrons. And large number of free electrons are present in metals, and therefore metals are supposed to be the good conductors of electricity. Let this conductor is connected a source of EMF, that is a battery. This is the positive terminal of the battery and this is the negative terminal of the battery. This positive terminal is connected to end A of the conductor, negative terminal is connected to the end B of the conductor. Obviously, A is at higher potential as compared to B, and B is at lower potential as compared to A. Therefore, the external electric field is developed here from higher potential to lower potential. This is the external electric field. The external electric field is developed across the every part of the conductor, at every cross section of the conductor. Whenever a charge is in electric field, it is acted by a force. Because we know that the electric intensity is the force on a unit charge. Therefore, force is acted on every charge. Similar to that, the free electrons which are inside the conductor are acted by a force, and the force is such that it is in the direction opposite to that of the electric field, because the charge is negative. On positive charge, there is a force of repulsion, and therefore on positive charge, force act in the direction of electric field, and on negative charge, the force is of attraction, therefore it is in the direction opposite to that of the electric field. इलेक्ट्रिक फील्ड मधल्या प्रत्येक चार्जवर फोर्स ऍक्ट होतो. इलेक्ट्रॉन निगेटिव्ह चार्ज असल्यामुळे इलेक्ट्रॉनवर ऍक्ट होणारा इलेक्ट्रिक फील्ड मधला फोर्स हा इलेक्ट्रिक फील्डच्या विरुद्ध दिशेत ऍक्ट होतो. Therefore, every electron is acted by a force in the direction opposite to that of electric field, and therefore all the electrons align themselves in the direction opposite to that of external electric field. And these electrons, free electrons, are supplied with the energy which is given by a battery, and because of that they start to move towards the higher potential. And when they start to move towards the higher potential, the empty space which is made available here is supplied with the electrons which are from the negative side of the battery. Like that, the electrons which are present in the conductor begin to move towards the positive of the battery, and the electrons are supplied from the negative of the battery, and hence the electronic current will be produced in the conductor from negative of a battery to the positive of the battery. The continuous motion of electron takes place from negative to the positive. But conventionally, the current is supposed to be the motion of positive charges. And at the start itself, I said that the absence of electron is nothing but a positive charge. Therefore, when this electron is supposed to move ahead, at that time, the positive charge is supposed to move back, and hence the conventional current is supposed to be in the direction of electric field from positive to the negative of the battery. Here, one thing that is to be remembered very clearly is that current is due to motion of electrons, no doubt about that. But the conventional current is supposed to be in the direction of positive charge. Therefore, the motion of electrons and conventional current are in opposite direction to each other. The electron moves from the lower potential to the positive potential, and the current flows from the higher potential to a lower potential. This is how the current flows through a conductor. This is how current flows through the conductor. इलेक्ट्रॉनची मोशन आणि कन्व्हेन्शनल करंट एकमेकाच्या विरुद्ध दिशेत आहेत. इलेक्ट्रॉन हा नेहमी लोअर पोटेन्शियल कडून हायर पोटेन्शियल कडे जाणार आहे, आणि कन्व्हेन्शनल करंट आपण हायर कडून लोअर कडे पकडतो, कारण कन्व्हेन्शनल करंट ही पॉझिटिव्ह चार्जेसची मोशन पकडलेली आहे. आणि इलेक्ट्रॉन जेव्हा पुढे जातो तेव्हा त्याच्यातलं एम्प्टी स्पेस, इलेक्ट्रॉनचं नसणं, इलेक्ट्रॉनचा ॲब्सेन्स म्हणजे पॉझिटिव्ह चार्ज विरुद्ध दिशेत जातो असं आपण इमॅजिनरीली पकडत असतो. Now, in a conductor, if I consider a cross section, let us consider, I will take a small cross section of this conductor. In this cross section of conductor, there is no accumulation of the electrons, because the electrons entering in the cross section is equal to electrons leaving the cross section. There is continuous flow of electron through the conductor. Because of that continuous flow of current through the conductor, electron entering the cross section will leave the cross section, and the number of charges, here the charges we are thinking are the electron, the number of charges crossing per unit time, the number of charges crossing per second is nothing but the current in the conductor. The current in the conductor is number of charges crossing per unit time. That is charge flown through a cross section divided by time taken. Charge flown divided by time taken, that is the current. And here very interesting to note that, and again that can be explained in the next chapter or later on by law of conservation of charges. The charges entering the junction are equal to the charges leaving the junction. Now here the charges that are entering in the cross section equal to the charges leaving the cross section. Therefore the flow of charges per unit time every time remains constant. Therefore the current is said to be the constant. The current is constant because the flow of charges per unit time remains set not only at this cross section. If you think of the other cross section also, the same amount of charges will enter the cross section and leave the cross section. Therefore current through the conductor is constant as far as the energy supplied to the conductor remains same. आपण आताच पाहिलं की कंडक्टर मधून करंट वाहतो म्हणजे काय होतं की कंडक्टर मध्ये आधीच असलेल्या इलेक्ट्रॉन्सला सगळ्यांना एका दिशेत आणण्याचं काम इलेक्ट्रिक फील्ड करतं, आणि त्या इलेक्ट्रिक फील्ड मुळे एका दिशेत आलेल्या इलेक्ट्रॉनला जी बॅटरी किंवा आपण सेल लावतो त्याच्या मदतीने त्यांची मोशन सुरू होते लोअर पोटेन्शियल कडून हायर पोटेन्शियल कडे. इलेक्ट्रॉन जेव्हा लोअर पोटेन्शियल कडून हायर पोटेन्शियल कडे जातात तेव्हा असं गृहीत धरलं जातं की पॉझिटिव्ह चार्ज हे हायर पोटेन्शियल कडून लोअर पोटेन्शियल कडे जात असतात. याचं खूप साधं उदाहरण आपल्याला सांगता येईल की धबधब्याचं पाणी नेहमी वरल्या उंचीवरून खाल्ल्या उंचीवर येतं. म्हणजे उंच असलेल्या खडकावरून पाणी खाली पडायला लागतं की आपण धबधबा म्हणतो. नदीचा प्रवाह उंचीवरून खाली यायला लागतो. म्हणजे नेहमी जेव्हा लेवलचा डिफरन्स असतो तेव्हा फ्लो शक्य असतो. आता जेव्हा उंचीच्या लेवलचा डिफरन्स आहे तेव्हा आपण म्हणतो ग्रॅव्हिटेशनल पोटेन्शियलचा डिफरन्स आहे तो. इथे असलेली ग्रॅव्हिटेशनल फोर्स वेगळा, इथे असलेला ग्रॅव्हिटेशनल फोर्स वेगळा, म्हणून याचे ग्रॅव्हिटेशनल फील्डची लेवल वेगळी, याच्या ग्रॅव्हिटेशनल फील्डची लेवल वेगळी, आणि म्हणून हे जास्त उंच आहे म्हणून हायर पोटेन्शियलला हे कमी उंच आहे म्हणून लोअर पोटेन्शियलला, म्हणून कुठलीही वस्तू वरून खाली येते विनासायास. तर नेहमी हा फ्लो हायर लेवलवरून लोअर लेवलवर येतो आणि इलेक्ट्रिसिटी मधली लेवल मोजण्याचं काम पोटेन्शियल करतं. म्हणून करंट हा नेहमी हायर पोटेन्शियल कडून लोअर पोटेन्शियल कडे असतो. एवढी गोष्ट लक्षात ठेवली तरी चालेल. इथे हाच भाग महत्वाचा आहे की करंट ऑलवेज फ्लोज फ्रॉम हायर पोटेन्शियल टू लोअर पोटेन्शियल. आपण जेव्हा एखादी बॅटरी लावतो, जेव्हा सेल लावतो, तेव्हा सेलचा पॉझिटिव्ह हा कंडक्टरचं पोटेन्शियल वाढवतं आणि सेलचा निगेटिव्ह कंडक्टरच्या दुसऱ्या बाजूचं पोटेन्शियल कमी करतं. आणि त्याच्यामुळे कंडक्टरच्या दोन एंडमध्ये पोटेन्शियलचा डिफरन्स तयार होतो. एक एंड हायर पोटेन्शियलला असेल, दुसरा एंड लोअर पोटेन्शियलला असेल. आणि जेव्हा केव्हा पोटेन्शियलचा डिफरन्स असेल तेव्हा इलेक्ट्रॉन लोअर कडून हायर कडे आणि पॉझिटिव्ह चार्ज हायर कडून लोअर कडे आणि मग चार्जेसची मोशन झाली की मग आपण म्हणतो करंट वाहायला. Therefore, the motion of electron takes place from higher potential to lower potential, and the conventional current flows from higher potential to lower potential. This flow of charges per unit time is called as current. 1 ampere current is the current in which 1 coulomb of charge crosses the given cross section of area per second. 1 coulomb of charge that passes through given cross section of area per second is 1 ampere current, and 1 ampere is equal to 1 coulomb per second. Now, whether the current is a scalar quantity or a vector quantity, whether the current is scalar or vector, this is the another question. Obviously, what current is? Charge upon time. Charge is measured in coulomb, time is measured in second. No, so many coulombs passing in so many times, the ratio of the two, that will give a current. Therefore, the current has magnitude. At the same time, current flows from higher potential to lower potential. Therefore, current has direction. Therefore, one may conclude that the current is a scalar quantity. But dear friend, what you will see that, let us consider now the current coming from this side is of 3 ampere, current coming from this side is of 2 ampere, the angle between the two is 90 degree, then how much is the total current flowing through this one? Now, this is the junction, let it is represented by A. The current coming from B to A is 3 ampere. The current coming from C to A is of 2 ampere. Then the current flowing from A to D, it should be of 5 ampere. At the same time, if current coming from this side, it is of 3 ampere. Current coming from this side is of 2 ampere, and the total current will be in this case is of 5 ampere. In both the cases, what you will see that the resultant current is the addition of the currents in the two branches, and it has nothing to do with what angle these currents are entering the junction. It means that for the addition of currents, we are not considering the direction through which they are coming, and it means that the addition of current doesn't obey the laws of vector addition. Vector addition will not be like this one. This 2 plus 3 is not 5 in vector addition. Similar to that, this 2 plus 3 is not again 5 in vector addition. In vector addition, we have to make use of law of parallelogram of vectors, and in that, the angle between the two vectors plays an important role to determine the resultant vector. And as the current does not obey the laws of vector addition, the current is not a vector quantity. In a broad, the current is supposed to be a scalar quantity. But at the same time, it is very important to note that, this is the 3 ampere current entering at this junction A, and out of that 2 ampere is leaving the junction A. Now, then what is here? the only 1 ampere current is flowing through this junction. Now, from C to A, the current is 3 ampere. Now, this current has two branches. One is from A to D and one is from A to B, and this current 3 ampere is split into two branches. Here direction is important. But again, it is not obeying the laws of vector addition. Therefore, current is a scalar quantity in a broad. But current has a direction. Therefore, if we go for the further studies of physics, current is supposed to be a tensor quantity. But up to the standard 11 and 12, you should remember that as the current does not obey laws of vector addition, we used to say that current is a scalar quantity. Thank you very much. Please subscribe and share my channel. Thanks once again.